this activity, we're going to look at one-step equations. We will solve single-step equations or one-step equations using reverse operations. What that means is if we see addition, we are going to subtract. If we see subtract, we're going to use addition. If we multiply, so we use the opposite operations. So here we see x plus 2 equals 5. We see a plus 2. We want to figure out what x is. We can kind of do this in our head, and we know that x should be 3. But using reverse operations, let's show our work. So we want to get x by itself. We get x all by itself. Here it is here. And in order to do that, we need to get rid of a plus 2. In order to get rid of a plus 2, we're going to use a reverse operation. So we will subtract 2. So to undo the plus 2, we're going to subtract 2. But in order to subtract 2, we need to keep the equation balanced. So we need to subtract 2 from both sides. Notice that I will have red on both sides of my equation, and it's a subtract 2 on both sides. Finishing up this question, I get x equals 3. This is solving a single-step equation using reverse operations. We were given an add 2 to undo an add 2 to get the x by itself. We need to subtract 2 from both sides. Just think of it like a balance. So then x equals 3. In this one, we have x subtract 3 equals 12. Again, we can probably just do that by inspection, knowing that 15 minus 3 is 12. But let's show using reverse operations how to get to the answer. So in order to undo a minus 3, because we want to get the x by itself, we're going to add 3. So to undo the minus 3, in order to get the x by itself, then we need to add 3. If we add 3 to this side, then we need to add 3 to both sides. Then we get x equals 12 plus 3, which is 15. And we have solved this equation using reverse operations. In this equation, we have 4 times some number equals 20. This number, again, just by inspection, we know that 4 times 5 is 20, so x is equal to 5. But I want to show it using reverse operations. So I'll rewrite the equation. To undo the times 4, we're going to divide by 4. We need to do that to both sides. When we do that, we end up with 4 divided by 4, which is 1, which is what we want, so x equals 20 divided by 4, which is 5. So to undo multiply by 4, we will divide both sides by 4. Notice that I always have red showing the reverse operations on both sides. One more question. In this question, we have x divided by 3 equals 4. To undo division, in order to get that x by itself, we need to multiply both sides by 3. Rewriting my question, I get x over 3 equals 4. And using my red to show my reverse operation, I'm going to multiply both sides by 3. Now, in this case, this 3 is in the denominator and this 3 is in the numerator. And 3 divided by 3 is equal to 1. So we get 1x equals 12. And that's what we expected. So in conclusion, to undo an add 2, we're going to subtract 2 from both sides to get x equals 3. To undo the minus 7 here, we're going to add 7 to both sides to get x alone and get 17. In this case, it's 3 times x, so to undo multiply, we're going to divide both sides by 3, and we get x equals 8. And finally, this is x divided by 5. To undo a divide by 5, we multiply both sides by 5,